Perfect. You can see our chatbot has responded. Hi there, how can I help you? About the basics of making an agentic graph. So till this point, we have learned how to execute a simple graph, state management, memory management. You can follow the previous session if you're new to this channel. Now, what we are going to do is create an agent and give it two tools. First one is calculator one, a calculator which takes a string literal and do the simple calculation. This is our custom tool, and one tool which is from LangChain community, DuckDuckGo, that will do internet search for us, and we'll define it in a tool array, and we'll just have to call dot bind tools on the Azure Chat OpenAI model. So that way, what we are saying is we are passing these two tools, and our model should have this information. Our state is very simple this time. It only contains the messages, and subsequent messages will get added as we receive them from multiple stages. So it's a very simple model node. It takes the state and it runs the state. It takes the state message, invokes our model, and then it returns the message, whatever be the response. Then it builds the state graph, add the model node, then it also add a tool node. See, this is important here. The previous code, it was same, just that we have not added the tools as an explicit node. Now you'll see what is going to happen. We are going to start and go to the model. Start node goes to the model, and then there is a conditional edge. Model can go take the route to the tool condition, and then tool can route to the model. So this is where, when if model thinks that it needs to pick certain tool, and it is going to take that route. Then from there we'll build the compiler, and this tool condition you can import from the LangGraph pre-built tool condition. From there itself you'll get the tool node. From there you compile this, and let's ask the question as how old was the second president of India when he died, and let's run it and see if we are getting the response. The second president of India was Dr. Sarvepalli Ramakrishna. Was born on 5th September. He died on 17th April 1975. Now, this is information that we got. And this is how, because it has bind the tool, it had called the DuckDuckGo to receive the information, and then from that information it constructed a final answer for us. Sorry for that. Now you might be asking, what if I want to force my model to use a certain tools whenever it receives a query? So because we want a control over calling the tools. In that case, we'll need to do some modification, which we'll see. So let's define. We'll keep everything same, and let's define we'll define a function which is, let's name it first model, and we'll pass this state, and it also returns the state, and we'll extract the query. What is the state message? The last one, the context. the content of the last message. So it could be the AI message or human. It will be, in most of the cases, it will be AI message. Then we can enforce here search tool call, and then we can make a tool call. And we can force it. So let's first import this. I think it will be, you can find this tool call in LangChain core messages. There is the tool call, and this is enforcing it to make a tool call, and then in the tool call we'll have to define which tool. So we have our tool as DuckDuckGo search, and in the arguments, what it takes the query and will pass the query, and second thing that we need to pass is the ID. So let's give it an ID is UUID 4 dot x. Perfect. And now return the message as AI message. We'll also need to import. Let's go there, AI message, and when we are making the tool call, since we know what needs to be passed, we can keep the context as empty, and there is one called tool calls. Here we can pass search tool call. Perfect. Now when we are going in the state graph, we'll need to add one more node as builder dot add node, and here we can define first model as the first model, then model node, tool node. Start will send this to first model because we want to enforce our model to make the tool call. Then the first model will go to tools node. So here we are removing the uncertainty. Now it will be a simple edge. First model will go to tools, and then we can build a dot add conditional edge. Here we can pass the model or tool condition, and then tool will go to the model. This is going to build it. Now this time when we are calling this, hopefully we'll see it. This time it has used the this time it has called the tool, but it was not able to find results. So what happened is, like, for this query it was not able to find any answer. Let's ask another query. Who won the last India versus Pakistan match? Today is date, time, dot, date, date, time, dot, now. Let's see if it gives an answer. So another, also, do you want the result of the match minutes? Which do you prefer? So it has taken it. Tool message is February 2025. Tried deleting all. So it's hallucinating a bit, but yeah, it's trying to call the DuckDuckGo. This is what brute forcing is. Here, what the important things is, we have not instructed the model how to use the tool properly, and that's why it is happening. But just to give you an idea, like this is how it's going to work when you're building a agent. But we just wanted to make you aware with the syntax. In the next upcoming session, we are going to do this full-fledged with in-memory vector store and many multiple tools for a model to select, and from there we'll carry on and we'll build our robust systems. Thank you. Till this point, we just learned how to make a graph. Now let's learn how to make a persistent memory. So doing that is actually very easy. The one way is very easy that I'll teach you. So you just need to import in the same code LangGraph dot checkpoint dot memory. Let's import memory saver, and we are going to use the same state and same builder. Let's use same model. Also, let's use same node. This is also going to be the same. The only thing that is going to change is when you do a compilation. There you can define your memory saver checkpointer. This is what we are saying. We are saying add the persistent sense with the memory. So let's make a thread. Thread 1, and it is going to be in this format. Is going to be, you need to define the configurable and the thread ID. So it can be a UUID. You can provide any ID. It should be unique one. Now the way you are going to invoke your model is going to be different. So let's comment this out, and till thread it, we just added the thread one, and let's bring our first AI message. So here you can see we are calling just the same thing. Hi, my name is Jack and this is the thread ID. So if you remember, if you invoke again, the model will lost the context of previous message. Let me run it. Now without this thread, if you are going to run it, and then if you make another invocation, let's make it result 2, and we'll ask what was my name, and we, as long as we provide the same configurable, then we can ensure that model will have this memory context with it. So let's run it and see if it works. Perfect. Hi, my name is Jack. This is the human message. Hi Jack, nice to meet you. How can I help you? Now this is the second message. You said your name was Jack. That's perfect. Now what happen if I do not pass this thread and then run it? Alright, we need to remove this as well. We need to compile it without checkpoint. You'll see uh, the difference. This is the first message. After that we'll have second message. If we are interested, what was my name? I don't know. You haven't told me your name in this conversation, and I don't have any just the differences. We just passed the configurable memory savers thread point, and that is the only difference that it made for the memory management. This is the one of the ways of doing the memory management, and it's very helpful if you want your uh, model to retain the context of the conversation like in a chatbot system. So this is how you are going to do it. Thank you. Starting the LangGraph series, and we have just completed the LangChain one, which is the basics for learning this new series. So I recommend you to go and check out that first, and then we are going to build some advanced agents. So without further ado, let's start LangGraph. So first thing first, let's learn about the memory management. So for that, from LangChain core.prompt, we need to import the chat prompt template. So chat prompt template. So this is the same basic LangChain stuff, but I'll tell you why it becomes important. So from LangChain OpenAI, import chat OpenAI if you are using directly from OpenAI, or we can use I am using, in my case, using from Azure. So everything remains same, just the object we have to import different. Now from .env, import load.env, and let's invoke it so that our environment variables are set up properly. Now let's define the prompt. PR, I hope that is visible. So from chat from template, from messages, and then we have to give the array of messages. So if you remember, we used to give the system and the placeholders. So we are going to do the same thing. Let me give you here. You are an helpful assistant. Answer all of the question based on your best ability. Question to the best of your ability. And in placeholder, then you define the placeholder. What would be the message? So now let's define the LLM. It is going to be Azure OpenAI, and we can define the model as GPT-5 mini. I'm going to use the GPT-5 mini. So now let's create our first chain. Chain is first prompt goes, and then the model. its LLM, and then let's invoke it. So chain dot invoke, and here what the placeholder that we have made, we are going to fill that, and let's pass messages as the array, and let's pass human AI and human message. To speed up the things, I have already written in my notes. So this is going to give us a response. So let's print this print response. Hopefully everything works fine. LangGraph memory. Okay. First, now let's run it. Okay, so it throws an error. List has no attribute. So I think I miss. Is it this correct spelling? Messages placeholder human AI. Okay, let me paste it here. Let me see what happened wrong. Azure Chat OpenAI model is 5 mini. Now let's run it. So translate this sentence from English to French. I love programming, and this is AI. What did you just said? I love programming and English back. So yeah, so that's how. This is just a refresher. Like this is how we create. We can understand as we create the human messages. Now, the next thing, the important thing that we are going to learn from here is the concepts of LangGraph. So we create a file, we name it state, and let's try to bring this much code from here and bring it over here. So we need to, now you will see how can we pass on the information as the states of graph. So let's, for the first thing, let's define a state which will take it from typed typed. Let's import it, and messages annotated list add message. So what it will do, it is going to append all the messages as it happens. So now we need to add the dependency of LangGraph, because we are going to use this aggregator. Perfect. And now we can import this from LangGraph dot graph import add message. What it will do, this state will append the messages as it gets, and the type of this field is this is a list. Now let's define the builder, like how. So let's make builder, which is a state graph. We'll also need to import it from LangChain.graph. So this is the state graph builder, and here you will pass your state. So we just passed our state. I mean, based on this state, build a state graph. Let's bring our LLM, Azure Chat OpenAI, and model is 5 mini. And now we have our LLM. Let's build our chatbot. So let's define chatbot state. It's going to take a state that we have just defined, and you will collect the response while invoking it. LLM.invoke, and we need to pass now the state dot message. See, we were getting the type hints because these all are Pydantic models, and we are also again going to return the same format messages. And what you will see as we interact with this chatbot, the memory will get built up for this graph, because we have defined it in such a way that as soon as any new messages will come, they will get appended. Now let's use our builder. Let's add a node because it's a graph, so we need to define the node. So let's make chatbot. There is only one node. This is the node, and then there are multiple edges. So builder dot add edge. So we have to, there's always going to be a start of a graph. So let's import it, and then same way there's going to be an end of a graph. So we can add start to the chatbot, and then let's also add an edge from chatbot to end. Now once you're done connecting your graphs, you can then go ahead and compile it. So let's graph builder.compile. This is going to compile your graph, and then to run this graph you'll have to pass the messages the way you wanted. So let's define the input messages. It's a list, and here we can pass human message. So let's import this from the LangChain code.messages. Import human messages, and then we can pass on here human messages, and let's start with sending a hi. Now let's see for chunk in graph gp dot stream, and then we can pass our input, and then we can print the chunk. Let's run it. LangGraph, state graph. Perfect. You can see our chatbot has responded. Hi there. How can I help you? I can answer question. And let's do one thing. Let's only print the content only. Okay, so with chunk we can't take this. Fine, let's run it. So this chunk is chatbot messages. Let's see if we are able to parse it. Perfect. So I think I need to go chatbot and then the messages from there. Let's try to get the first one. Perfect. So that's how you can parse it. Then you can go dot content. So this is, I mean, based on the response of an AI, you just print it and you'll be able to learn it. No need to remember anything. So chatbot messages, first content, and then the content. This is where you get your output. So this is how you build your first state graph with the help of LangGraph. Important thing is we learn like how to start a graph, how to end a graph, how to add the edges, how to build the nodes, and you have also seen me making some error, how to fix them, how to build the states. These are the important things that someone needs to remember while they are building the graphs. And in the upcoming session, what we are going to learn is how, because right now if you see, as soon as I run it, it lost its memory, but we'll learn how can we preserve the memory, the persistent memory saver of the LangChain. And from LangGraph, there's called something called checkpoint.memory, which we are going to use for the upcoming session. Thank you. Now we are going to do a reflection system. This is where we want our nodes of the graph to continuously communicate back and forth until our desired criteria is not met, or if there is a condition, logical condition that is breaking. So we are going to continue with GPT-5 model. We are going to keep the simple state as a message, and in that base messages we are going just adding as the messages are coming from AI human, and we have defined two prompts: a generate prompt, a reflect prompt. The generate prompt, what we are going is like we are generating an essay, and then we are doing a reflection from an LLM to see uh, if that submission has good style, include depths and all things, and it is going to provide the recommendation. So this is the objective. How can we build such system? What is the first things that we need to know? So one thing is clear, that the generation graph is straightforward. It is going to take state. It is also going to return the state, and we are going to invoke the model. we'll first pass the generated prompt plus the state message. Well, let's say whatever be the requirement, and then from there we can return the message as response. We need to wrap this around as rest. Now the reflect one is also going to take the same state. Now we need to invert the message to get LLM to think on its own output. So let's do the mapping. Is what AI message will invert to human message. Human message will invert to AI message. So that's how you will make it think its own output as the human message. So now let's do the translation. So the first message in is the original user request. We hold it same for all node. So let's do the reflected prompt and state message. The first one is the human one. So this is going to be the base. And after that, you'll have to go the class mapping and message. So for message in state messages, except the first one, because that one we want. And what we need from here, so let's first do the message dot class for class dot map dot message, and then we want the content of this message. Class message class content for message in state message. Perfect. So what we are doing, we are just reflecting it on its own output based on what class it is. So AI message, AI will become human, human will become AI. So this is the switching that we are doing here. Let's collect the response. Model.invoke, translate it, and then we can return messages as human message because it is doing the critic, and content we can pass the response dot content. Now this can go on and on and on, but we need a condition which is like should continue. State. So if the length, let's make a condition, state message is greater than 5. In that case, we are going to return the end node, else we are going to return reflect node. And these node we are going to define when we are building the graph. So as the last step, let's build the graph. Builder state graph takes the state, and builder dot add node generate, then reflect is going to be the reflect, and then we can start adding the edges. Start will go to generate, and from there add conditional edge. From generate we can go to should continue, and then builder dot add edge from let it is going to generate, and our end condition will be invoked by should generate. So builder dot compile. So we have to pass an input state. It is going to be a message. Human message. Content. Write an essay about AI. So this is going to be the things that we want our state graph to do. Graph dot stream input state. We can collect the message type is generate out else let us reflect. So let's print the very last message. Let's run it. So I'm ready to write. Would you like? Please tell me about preference, purpose, and audience. So this is the first message that our AI asked to the AI itself. Let's see what will be the output. So it is doing the reflection, and depending upon the LLM, it might take more time. So for me, it is taking some time, but I hope that you get the idea. And I'm not going to extend this video more. It's already become quite long. Thanks for joining. Next, in the next uh, session, we are going to learn about the subgraph, how to invoke a smaller subgraph from parent graph, like parent-child relationship. And till then, thanks for joining.